Alright, so the third page is basically just going through a few examples together. And so we're going to just find the equation of planes through different scenarios. In the first scenario is we have a point and we want it to be perpendicular to a line x equals 3t, y equals 2 minus t, and z equals 3 plus 4t. And so if it's perpendicular to this line, then what I really want is just the normal vector for the plane that I'm dealing with, and what I want is the initial point. We'll already have an initial point. That's given by 2, 0, 1. So we'll go ahead and write that as my initial point. And so we have 2, 0, 1. And so all I need now is the normal vector. Alright? So when we find the normal vector, we're going to be good. Now, if it's perpendicular to this line, then basically I want the vector of this line. And it would be great if I could find that vector pretty easily. And I can. One thing that I want to note up is when we were doing the parametric equations. Alright, when you have a parametric equation, notice that every coefficient with the t makes up that vector. So therefore, if I'm having a vector equation of a line, that is a vector of this line, then it's going to be perpendicular to my plane. So I want the vector of this line. So let's go ahead and find that. So the vector of that line is going to be given by all of the coefficients. And so 3, -1, and 4. So now I have the normal vector. So now it's going to be pretty easy to find the equation. So normal vector, x minus whatever our component is for the point, which would be 2, plus, in this case minus because it's -1, y minus 0, and then plus 4 times z minus 1, and that's equal to 0. Alright, now let's clean it up and solve it. We get 3x minus 6 minus y plus 4z minus 4 equals 0. And then I'll just clean up to where I have all my variables on one side and my constant on the right. So I have 3x minus y plus 4z is equal to -6 minus 4 is -10. Take it to the other side, becomes +10. And we have our equation for the plane. All right, it's not very difficult. We just need to make sure that we have a normal vector and we have a initial point. All right, again, notice one thing too is that when you're writing the equation of a plane, you'll have all your components for your vector are going to be coefficients of your x, y, and z. All right, and that could be very important depending on the type of question that's asked. All right, example 5. Find an equation of the plane through point 2, 4, 6 and parallel to the plane z equals x plus y. All right, so finding an equation of the plane, we want an initial point. We have an initial point. Our initial point is just 2, 4, 6 because we're told that that point is on the plane. And we're told that our plane is parallel to another plane, zx plus y. Well, if our plane is parallel to another plane, then the vector of the plane that we're parallel to can also be a vector that I can use on my plane. So what I want to do is I want to go ahead and I want to look at this plane and I want to find out, what's your vector? Because it's going to be the normal vector because this is an equation of a plane. And so what I'm going to do is I'm just going to rewrite the way that this looks. I'm going to say 0 is equal to x plus y minus z. And of course, from up here, we were saying, oh, every coefficient with our variables are going to be our normal vector. So then the normal vector for this equation, because this is an equation of a plane, is just 1, 1, negative 1. And now what I can do is I can write the equation of my plane. So I have the equation 1 times x minus 2 plus 1 times y minus 4 minus 1 times z minus 6, and that's equal to 0. Combine all my like terms. Well, just go ahead and combining everything. X minus 2 plus y minus 4 minus z plus 6 equals 0. Combine what I have, x plus y minus z is equal to, and it looks like it's 2, negative 2 minus 4 is negative 6, plus 6 is 0. And it turns out that, it's the same plane that we're dealing with. And that could work out, and that's okay. So what this means is that 0.246 was already on the plane that we were using, and so we just kind of confirmed that, oh, this is the plane that has the 0.246. We were already dealing with that plane. All right. Again, that's totally okay. This means that we were actually working with the same plane. It's based off of that point that's given. All right. If that was 247 and, it deviated by, our answer deviated by 1, then you would see, oh, okay, it's parallel. But here, because 246 is actually on the plane that we were using to help find our normal vector, that's why it looks like it's the same. Well, that's why it is the same. All right. So example 6. Find an equation of the plane that contains the line x equals 1 plus t, y equals 2 minus t, and z equals 4 minus 3t, and is parallel to the plane 5x plus 2y plus z equals 1. So now what I want to do is I'm going to use this line, all right, that, our plane has to contain this. So hopefully what I'm able to do is I'm able to establish, okay, if I'm given a line, is there a way I can find a point through all that? And there is. All right, instead of now taking the coefficients with our t's, we just want to find an initial point. So now we're kind of taking all the constants. And so our point that we're going to be using is just the constants of this line, and that's going to be 1, 2, 4. So we're just taking all the constants of our equation, and it says that it's parallel to another plane. So we're going to do the same thing we did last time. We're going to be able to find our normal vector based off of the plane that was given because we're parallel to that. So we're going to have the same, it can have the same normal vector. So we have 5, 2, 1, and this is taken from, again, all the coefficients of that second equation of a plane. And now we'll go ahead and set up our equation. And so we have 5 times x minus 1 plus 2 times y minus 2 plus 7. Oh, that's not 7, that's a 1. Plus 1 z minus 4. Set that equal to 0. And let's clean it up. 5x minus 5 plus 2y minus 4 plus z minus 4 equals 0. And 5x plus 2y plus z is equal to, minus 5, minus 4, minus another 4. And we are going to get minus 13. Add that to the other side, and that's positive 13. And so there's our solution, or there's our equation of a plane, of that plane. All right, one more where we're going to find an equation of the plane through the points 3, -1, 2, 8, 2, 4, and -1, -2, -3. So it's great in the fact that, oh, hey, you know, I can choose any of these points that be my initial point, and I'm going to use P, but let's call these points P, Q, and R. And there's a problem with this one, and the problem with this is I need a normal vector, and all I have is points. So what I'm going to do is I'm going to go ahead and, okay, let's make a few vectors, because I know that if I take the cross product of two vectors, what I will get in return is going to be the normal vector. And so that's my hope, is to find two vectors and then take the cross product of that to find the normal vector. Again, that was last section of notes. And so I'm going to find my PQ vector, and that's just going to be 8 minus 3, 2 minus -1, so plus 1, and 4 minus 2. And so I get 5, 3, 2. And then I have a vector of PR. And I'm going to do the same thing, take the difference. -1 minus 3, -2, minus a -1, so plus 1. And then -3 minus 2. And I'm going to be getting -4, -1, -5. Alright, so now I have those two vectors. If I'm going to find the normal vector, it's going to be the cross product of these two vectors. And so I'm going to go ahead and label everything I, J, K, 5, 3, 2, -4, -1, -5. And now I'm just going to go ahead and show the cross product. So 3 times -5 minus 2 times -1 I plus, minus, and then 5 times -5 minus 2 times -4 J, and then plus 5 times -1 minus 3 times -4. Okay, and now we're going to go ahead and do the math. So we get -15 plus 2, so we get -13 I. And then we get 5, so 5 times -5 is -25, -25, 2 times -4 is -8, so plus 8, so -25 plus 8 is -17, but then times a negative only outside, so it's going to be plus 17, so 17J. And then the last bit, 5 times -1 is -5. And then 3 times -4 is -12 minus a -12, so -5 plus 12 is going to be 7, so plus 7. Okay. Plus 7K. And here we have our normal vector. And again, you can rewrite this normal vector as -13, 17, and 7. And now we're going to go ahead and write the equation of our line, or equation of our plane. So we have an initial point. So I'm just going to use this as my initial point. And I'm going to have my normal vector. So it's going to be -13 times x minus 3 plus 17 times y plus 1 plus 7 times z plus 2, and that's equal to 0. Alright, just to save some space and doing the math, I think everybody can do this type of math. We'll have -13x plus 17y plus 7z, positive 39 plus 17 is going to be 56. 56 plus 14. And making sure all the math is correct. Oh, I do see there's a problem right here. That should be minus 2. So 14. So then that will give me 56 minus 14 is 42. So subtract 42. And we're equal to negative 42. And there is